So, the other type of electrochemical cell we need to look at, like we just described, is an electrolytic cell, which is much more simple. It uses a battery, which we would normally represent like that. Batteries have a negative side, negative terminal, and a positive terminal. So in this case, my electrons actually, they are forced to go in one direction. Raquel, which direction do my electrons go from my battery? To the left, exactly. They are going to go this way because the battery makes them go this way, which means I suddenly have these negative things building up on that piece of metal. So that becomes a negative electrode. And if that's a negative electrode, what must the other one be? It must be the opposite. This must be the positive electrode. Okay? Now, I've got my things floating around in solution down the bottom. Let's say it was something like silver chloride, like we just talked about. Silver chloride, if it's in solution, breaks up to form some silver ions, some chloride ions. They're all floating around. So, Raquel, which of those things floating around in the solution are my silver ions, blue or red? Which are the positive ones in solution? The red ones. So if I've got positive things floating in my solution, and I've now got a negative electrode, a negative piece of metal there, those silver ions are going to be attracted over to that electrode. Ah, you thought it was a trick question. Good. So as soon as they get there, like we just said, what happens is we end up with these positive silver ions moving to that negative electrode. When they get there, they pick up an electron and they become nice silver atoms. So I start to see silver collecting over that negative electrode. What about the other side? The other side is going to be my positive electrode. What gets attracted to the positive side at Raquel? The negative things, which in this case are chlorides. What process have we just talked about happening over on the left? Is that oxidation or reduction? Is this silver thing here getting an electron, or is it giving one away? If I write Mr. Canning plus pencil case, is that me getting a pencil case, or is it me throwing one away?
The other equation is separating two things?
That's what it was afterwards. If I write an equation...
Is this talking about
I'm talking about on the left side here. I'm talking about this equation we've written, this half equation on the left here.
That is losing.
Right. Let's look on the right side where my products are. On the right side...
something plus something, you need something, you're adding them together.
It does. But that only means that if it's on the left. On the right, where the products are, if I have something plus something else, that means those two things are produced separately. Does that make sense? Yes or no? What's happening here? Is that silver plus gaining the electron? Or is it gaining it? What is gain? Is it oxidation or reduction?
Reduction.
It is reduction. So this is reduction. Therefore, what must happen at the other side? Oxidation. So if we go over to the other side, I've got these Cl minuses, these chloride ions, all being attracted to the positive terminal, the positive electrode. When they get there, what's going to happen? Hello. What is going to happen? They've got a negative charge, which means they've got an electron that we've just decided they're going to lose. So if we wrote the kind of opposite equation to the first one, we would have something that looks like this. However, what's the normal state of chlorine? What do we find it? It's a bit like oxygen or nitrogen or hydrogen. We find it's a chlorine gas, which actually has the formula Cl2. So just to make sure we balance this little half equation, just like we do with the redox equations, that really long, boring process, how many chlorines must I have on the left? 2 as well. And how many electrons must be released if I've got 2 negative things, yeah? I must have 2 of those. We've said that must be oxidation. If I check carefully, yeah, on the product side, I've produced 2 things. I've produced some chlorine gas and I've produced electrons. So it's lost electrons. Okay, so again, reduction on one side, therefore oxidation on the other side. So in this case, if I actually looked at that positive electrode, what would I see with my eyes? Well, I see bubbles. If a gas is forming there, I'd see bubbles. Do you know what colour chlorine gas is? By any chance? It's actually kind of yellowy-greeny. Yellowy-greeny. You don't need to know that. It is yellowy-greeny. If I was looking at the left side, what would I see there? I would see silver colour, like the metal, the silver that was being formed there, I would see forming. Depending on what my piece of metal is, it might be attached like a layer on the metal, or it might drop to the bottom. Exactly as we did in the lab today. Okay, and that is it. That is electrolysis.